Bismillahirrahmanirrahim. Assalamu alaikum. I'm Usman Ali, Assistant Professor of Chemistry, and today we are going to discuss important article of chapter number 5, first year chemistry. But if you have not subscribed my channel, please subscribe my channel, press bell icon so that you can get whole of my videos live on YouTube. So the article today is wave particle nature of matter, or this article can also be dual nature of matter. Max Planck was the first scientist. Max Planck gave the idea because light has dual nature. Dual nature mean double nature. Double nature mean it will show two properties. Number one, wave-like properties, or number two, particle-like properties. If anything having particle-like nature, it will show momentum. As we have studied about the properties of cathode rays are material particle because they can rotate small paddle wheel, because cathode rays have mass and velocity. Product of mass and velocity is called as momentum. Anything having momentum will carry particle nature. It can have mass and velocity. Anything having wave nature, it will show crest and trough, and the distance between them is called as wavelength. It means anything having dual nature, it will show two properties, wavelength and momentum. Wavelength and momentum. In 1924, de Broglie was the scientist who gave the idea that matter like light will also show dual nature. Matter like light will also show dual nature. Mean it will also show wave-like property and particle-like property. Now, the definition of his idea was the moving object, electron, proton, neutron, atom, molecule, when move, they show wave-like property plus particle-like property. They show wave-like property and particle-like property. So they are the matter. They are the matter. Matter, which things are present in matter? Electron, proton, neutron, anything. Atoms, molecules, when move, they show wave-like property and particle-like property like light. This is called as wave, particle, duality of matter. Wave particle duality of matter. The idea of Max Planck is applicable. It is applicable. It is its definition. It is applicable on microscopic plus macroscopic particles. It means his idea is applicable to small particle to very large particles. Small particles are microscopic and large particles are macroscopic. The idea or the equation, it means if atom, molecule, electron, proton and neutron show dual nature, so they can show two properties, momentum and wavelength. He gave the relationship between wavelength and momentum h over mv, where mv product of mv is called as momentum, whereas lambda h is called as Planck's constant, lambda is called as wavelength. This equation was called as wave particle duality equation, or it can also be written as de Broglie equation. How he was able to derive this equation? How de Broglie was able to derive this equation? He used the idea of two scientists from Max Planck's quantum theory and from Einstein energy mass relationship, E is equal to mc square. Energy mass relationship from Max Planck's, it is H is equal to E is equal to h mu. Relating these two equations, both are equal to energy, hence h mu will become equal to mc square, where mu is equal to c over lambda. Putting value of mu, it will become h c over lambda, it will be equal to mc square, where lambda will become on other side, lambda will be equal to hc divided by mc square, where c and c square will be cancelled out with one another, hence lambda will become equal to h over mc. C is the speed of light. C is called as speed of light. For electron, C is replaced by V. So V is the velocity of electron. C is for light. It's the speed of light. For electron, its speed is changed by V. Hence lambda will be equal to h over mv. This is called as de Broglie equation. We have already written this one and we have proved this equation. From this equation, we will be able to calculate the wavelength of electron. In first shell, according to Bohr atomic model, we have little idea about two forces. First one is centrifugal force and the second one is Coulomb force. Centrifugal force is equal to mv square over r. This one was equal to ze square over 4 pi epsilon naught into r square. R is cancelled out with r square and r will become v square. It will be written on this side and it will be equal to z square 4 pi epsilon naught r into m, and by taking a square root on both sides we will be equal to calculate the v velocity of electron in first shell. The first shell radius is 0.529 angstrom. From the first shell, the velocity from this formula, we were able to calculate the velocity of electron. It was 2.18 into 10 raised 2.18. We will be able to calculate the velocity of electron into 10 raised 6 meter per second. The velocity of electron in first shell. So the wavelength will be equal to h over mv from this equation, h is equal to lambda, h is equal to 6.626 into 10 की power minus 34 joule second divided by mass of electron 9.1, 10 की power minus 31 into velocity of electron 2.18 इतने kg, 2.18 into 10 raised 6 meter per second. By solving this equation, lambda will be equal to 0.33 nanometer. 0.33 nanometer. This was the wavelength of electron in first shell. Hence, we have already studied about the particle nature of cathode rays. If wavelength is existing, so wave will also be present. So both properties are present, particle like nature from paddle wheel and wavelength if it is present, so wave is also present. So in electron both natures are present. Number one, the particle like nature, number two, the wave nature from wavelength. For proton, if we want to calculate the proton, first one we have to memorize first idea as lambda is equal to h over mv. From this formula we are able to calculate wavelength is inverse of mass. If mass is increased, the wavelength will decrease. If mass is increased, the wavelength will decrease. As proton is 1836 times heavier than that of electron, so its wavelength, if mass is greater, its wavelength is 1836 times less than that of electron, because wavelength and mass are inverse to one another. For alpha particle, if alpha particle are there, for alpha particles are helium nucleus. There are 4 times, their mass is 4 times to that of proton, and one proton is 1836 times larger than that of electron. Mean alpha particle how much heavier than electron? 7344 times. If it is how much heavier, its wavelength will be 7344 times less than that of electron. So if we go on increasing the mass of particle, its wavelength will be decreasing continuously. From this we can calculate another thing. Say there is a person, if there is a person who throw a particle, a stone thrown by a person does not have wave, we have to prove it. Let's suppose the mass of stone is 1 gram. It will become as 10 power minus 3 kg by dividing it by 1000. It is thrown by the velocity of 10 meter per second. So its wavelength will be equal to lambda is equal to h over mv. H is equal to 6.626 into 10 की power minus 34 divided by mass of electron, or mass of stone is 10 की power minus 3 kg and its velocity is 10 की power plus 1 meter per second. Its wavelength will become 6.626 into 10 की power minus 32 per meter. Its value is too small. इसका मतलब है इट मीन दैट वेवलेंथ इज टू शॉर्ट टू बी नोटेड with naked eye, mean we cannot calculate the wavelength by naked eye, as wavelength is too short and crest and trough are very close to one another. If crest and trough are very close to one another, we can say that there is no wave attached to it. Wave attached to it, mean overall we can say that there is no wave, but wave will exist, but wavelength is too short to be noted by naked eye. So we can say that there is no wave attached to a stone thrown by a person. There is no wave attached to a stone thrown by a person. Now the next thing is about, we have to experimentally calculate the article is finished to here on. If it come as a long question, you have to write till now. Now the next short question is calculate wave nature of electron. Particle nature was already discussed in the start of this chapter. Wave nature of electron. This work was done by two scientists. The first one is Davison and the second was Germer in 1927. They produced cathode rays. They produced cathode rays by heating this W tungsten filament. By heating it, they produced cathode rays. Cathode rays are merely electron. By applying high voltage, they applied high voltage across them and they are accelerated. They are accelerated and pass through slit. They collide with, next in their path there are the presence of nickel crystal. After striking they will accelerate, and after striking nickel crystal, if they are material particle, they will bounce back. But after striking this nickel crystal, next there is the presence of zinc sulfide plate. They will change their direction at some angle. The changing of direction is called as diffraction. They are diffracted like X-rays. If they are material particle, they will bounce back, but they have diffracted like X-rays. So the diffraction is the property of waves. This shows that they have wave nature in them. Hence Davison and Germer justified the idea of de Broglie that there is the presence of wavelength and wave nature. If they are material particle, they should bounce back, but they have diffracted. This shows that they are wave and there is the presence of wave nature. For this, they were awarded the Nobel Prize in chemistry. They were awarded about the Nobel Prize for this work to discover the wave nature of electron after the work of de Broglie. He just gave the idea of wavelength and they experimentally proved that there is the presence of wavelength because they are wave nature. Why they are wave nature? Because they are diffracted after striking a nickel crystal. This is the whole idea of wave particle duality of matter. Allah Hafiz.